Right. So our last set of notes came from that whole like 3-quadrant piece. I'm going to add to that. So this is what we had from Thursday, I think, or Wednesday to take all those notes. And then now I'm going to add to that section because there is one other thing called a segment area. So if you want to do this, you can. So section 10.1 continued. All right. So this is finding a segment. And a segment in this example is actually area. So finding a segment of a circle. Segment is actually an area, and you'll be able to tell that just because of the way that it's shaded in. So here's our problem that we'll work with. Let's do, so we'll do a radius 21, and we will do these in decimals, okay? Well, I guess we don't have to. Let's see. Let's do 12, I guess, and then let's do 120 here. And again, they don't have labels, which kind of defeats the purpose, but I'm going to put inches for us to work through today. You can do the same on your worksheet. A segment is actually this amount right here. And it's very obvious, you guys, it'll show you. So you probably saw it yesterday on Pearson, how they had that piece of it shaded in. Here's an example of what it will look like. It's an area, so it's not confusing. It will be shaded in appropriately when you see it. The whole idea of finding a segment, and I might, if I need Max to shut the other light off, I wonder if that'll help. Might not help us stay awake, but alright, thank you. Is to find, first of all, the area of the sector. Okay, so the area of the sector, which is the whole piece of the pie that got eaten. That was eaten, maybe is a better way to say that. So you're going to find the area of that sector, and then you're going to subtract out the area of the triangle. Okay? So the area of the sector is the whole piece of the pie, and then the area of the triangle is obviously the triangle, and then you're going to come up with the remaining pink piece, which is what our goal is. So this is the whole idea. We know the area of a sector formula is, for our purposes, 120 over 360 multiplied by 2 pi r or pi r squared?
Pi r squared.
Very good. Pi r squared. And then the area of the triangle, 1/2 base times height. Is the 12 our base or our height at all in this example? No, it's not. Our height is here. We don't have it. Our height is here, and our base is across the bottom here. So we don't have either of these, so we can't fill in any of those numbers. We'll have to find those. So step 1 is to just find the area of the sector. So we have that at least written down. Let's do that. 120 divided by 360, how does that simplify?
1/3.
Okay, 1/3 pi times 144. Is 144 divisible by 3? You guys remember the shortcut on how to figure that out?
Do you add it all together?
Yes, good. If you haven't remembered that, that's a good one to know. If you add 4 plus 4 plus 1, what's our total?
No.
If 9 is divisible by 3, then it is divisible by 3. So what is 144 divided by 3? What'd you say? 28? 48. Okay. 48 pi is the area of our sector then. So that's step 1, and I have it stepped out for you on the worksheet. I don't know if we'll actually get to it, but it is. Yes.
Does that work for only 3, or is that for other
It
numbers?
works for 3, and if you're questioning if the number is divisible by 9, if the number is divisible by 3, then it's worth a shot on trying if it's divisible by 9 or not. It's not a guarantee, but a number can't be divisible by 9 if it's not already divisible by 3. If that makes sense.
Right.
So, it's worth checking.
But this only works for 3.
It only works for 3s. Yeah. Yep. All right. But you can use the combo of it, Adam, because if it was an even number, like 144 is, and it's divisible by 3, then you know it's also divisible by 6. So, I don't know. Anyway, another lesson for another day. Area of the triangle, this is the beast right here. You want to find, using trig or special right triangles, that area right there. And I'm a big fan of pulling it out and drawing that picture. Give yourself that right triangle. You know how they kind of do that sometimes in maps? They blow it up. Let's do that. I know I can mark this as 12, because that was my radius. So I know my hypotenuse is 12. What's the angle here? So 120. What's it going to be here?
60.
60. Okay. So I need to come up with, this is my height. I'm going to call it H. And this is my base, but it's only half of the base. So I'm going to call it X, because then it'll force me to know that I have to double it to find the base. Do you want me to do trig with you or special right triangles?
Special right triangles.
It's way faster if you do special right triangles, and most of the stuff you'll see today will be that way. Hypotenuse and short leg are doubles. So if the hypotenuse is 12, what does that force the short leg to be? 6. The short leg and the long leg, one is the product of, yes, 6 square root 3. So you multiply by the root 3. So x is 6 root 3. All right, perfect, because now I can go ahead and plug in what I have. So my height gets a value. The base doesn't have one yet, but I'm close. How do I take 6 root 3 and double that? What do I get when I add 6 root 3 plus 6 root 3?
12 root 3.
Yeah, 12 root 3. Okay, so now I have half 12 times square root of 3 times 6. So I just want to do half times 12, which is 6, and 6 times 6, which is 36. Leave the square root of 3 out of it. It's kind of like a pie. Can't touch it. So you end up with 36 root 3 for the area of the triangle. And then you're done. You cannot simplify that. That is in its most basic form simplified. So I call it done and I tack on a label. You suppose I should inches or inches squared that label?
Inches.
Inches squared. So sector area is measured in squared units. Units squared. So feet squared, inches squared, etc. Okay? So that covers the concept that I had you watch that video on yesterday. It is also on the worksheet today, which is on Pearson. So